You are making a game, and you have figured out how to draw a sprite to the screen. Great! Perhaps you have even figured out how to make it move. But something is missing. What you need is Sprite Animation. A sprite is just a 2D image. To animate it, we are going to use the same technique used for movies. A movie is just a long strip of 2D images, shown one after the other in a rapid pace, giving us the illusion of movement. The easiest way to implement this is to have every frame as separate images. Note that I am not an artist. These sprites are made by Louise Melot. In code, we create an array of textures and load each frame into the array. We then draw one of the textures to the screen. Right now, we're only drawing the very first frame. So let's change that. Instead of only drawing the first frame, we want to keep track and change what index in the texture array to draw. So we create a variable for the current frame index. Each update, we move the index to the next frame. And if we reach the end of the texture array, we loop back to the beginning. And then we draw the texture at the current index. Let's see this in action. Oh no, this is too fast. That is because we are changing the index every time the game updates, which in this case is 60 times per second. To solve this, we want to limit how often the index is changed. One easy way to do this is to keep track of how long we have spent on the current frame. And if that time exceeds some threshold, we then move to the next frame. We add a variable for how long we should spend on each frame. In this case, we want to play the animation at 8 frames per second. We add another variable for keeping track of the time we have spent in the current frame. The update method now takes delta time as an argument. This is the duration since the last time the update method was called. We update the time since last frame with the delta time. And while we are exceeding the threshold of 8 frames per second, we rewind the time since last frame with the time we expect per frame. Move to the next frame and make sure we loop back to the beginning if we go outside the texture array. We use a while loop just in case we get a lag spike. If the delta time is very large, then we might need to move more than one frame in a single update step. Let's see if this made it better. There we go. Now the animation is running in a more reasonable speed. But using separate textures for each frame is a bit wasteful. It would be better if you could combine all individual frames into a single texture, a sprite sheet if you will. We could then just draw a small subregion of the larger texture. Instead of keeping track of textures each frame, we just have to keep track of the subregions. We need a place to store the big texture. The frames array is now an array of rectangles. We'll load the big texture and fill the frames with rectangles. This is a simple way to do it. Just hardcode each rectangle. But because we know that each frame is the same size and is spaced evenly, we can create rectangles algorithmically. We calculate the width of each frame by dividing the texture width with the number of frames. We then iterate over each frame and create a rectangle for that frame based on the calculated width. Let's see this in action. Awesome! But having so much empty space between each frame still feels a bit wasteful. What if we pack each frame closer to each other? This makes the texture smaller, but it also means that we have to rethink how we use the subregions. Each subregion will now have a unique size and offset. This means that we have to go back to hard coding the rectangles again. It's a trade-off for a smaller texture size. Let's see this in action. Oh no, what is going on? The animation is shaking somehow. This won't do. The reason is that each frame now has their own sizes, but we're still drawing from the top left corner. If we overlap the frames, we can see that while the frames themselves are drawn in the same position, the character is not. We solve this by changing what part of the image we want to use as origin. I prefer to place the origin at the feet of the character. If we now overlap the frames, we can see that the character is drawn in the same position in both frames again. In code, it looks something like this. We have to define a new data structure for our frame, because they now need both a rectangle for the source, or subregion, and a vector for the new origin. Instead of having an array of rectangles, we now have an array of frames. We then have to fill this frames array with the new frame objects. This can be done by hand, like I have done here. Or, if you want to go the extra mile, you could load this from file. Maybe a file you have generated from a custom tool that takes each individual frame and packs them in the most optimal way, and provides you with a graphical editor for selecting the origin point. But that is outside the scope of this video. In the draw method, we take the position we want to draw the sprite at, and the origin of the current frame, and combine them, before drawing the frame to the screen. You have now gone from drawing a single static sprite to animating that sprite, and I have shown you a few ways on how to approach the problem. This video is part of a series where I try to figure out what kind of videos I want to make. So, if you like this video and want to see more like it, then please let me know. Thank you for watching, see you in the next one.